In this session, I'm going to continue the introduction to data flow diagram. We need to draw a collection of data flow diagrams. First step, we draw a context diagram. And then we decompose the context diagram to level 0 diagram, which is also called diagram 0. And after that, we decompose level 0 diagram into lower levels of diagrams, such as level 1 diagrams, level 2 diagrams, so on and so forth. First of all, we need to draw a context diagram. This context diagram has the most abstract view of the entire system, because the entire system is represented in this diagram as a single process, which is called process 0. In this diagram, we also show external entities, which are connected to process 0 through data flows. Let's consider a very simple case. Suppose we want to describe a system that allows users to register their new accounts. In the registration process, a user needs to provide a username and also password. And here, the user needs to enter password twice. So two pieces of information regarding password should be provided. And based on that, we can draw a context diagram, just like this. So here, we have only one process, which is process 0. And this process represents the system. And the name of the process is just the name of the system, which is registration system. Also, we have an external entity, which is called user. And this user provides username and also password to this registration system. On the other hand, this system also provides information to user, depending on whether the registration is successful or not. It either outputs registration complete information to user, or it outputs error message to user. So this context diagram hides the complexity of the system because it represents the system as a black box. So its internal components are just hidden inside this black box. If we wanted to describe this registration process, then we could draw a context diagram like this. In this context diagram, we have one process, which is called process 0. And its name is registration system. So here, the entire system is just represented as a single process. Also, we have an external entity, which is called user. This context diagram also includes all of the communications between this external entity and the system. So as you can see, the user needs to provide her username and also password to this system. And also, the system provides feedback information to user. Depending on whether the registration process is successful or not, the system provides either registration complete information to the user or an error message to this user. So here, this context diagram hides the complexity of the system because all of the internal components of the system are hidden inside this box. And then in the second step, we need to decompose this process 0 and create level 0 diagram, or diagram 0. A level 0 diagram shows more detailed information about the system. In this diagram, we show the major components of the system. In other words, the entire system is decomposed into several major processes. We also need to describe the communications among those processes. We may also include data stores So this diagram also shows the external entities. So we include external entities in the context diagram as well as the level 0 diagram. Also, each process in level 0 diagram has a reference number, such as process 1, process 2, so on and so forth. This reference number has nothing to do with sequence. So it doesn't mean we need to first do process 1 and then process 2. So this time we draw level 0 diagram. So the system is decomposed into 3 processes. Process 1, process 2, process 3. Process 1 receives inputs from user, that is, username and passwords. And it checks if username and passwords are valid. So this validation process requires a third input, which is from this data store. Because a valid username must be new and must be unique. So given a username provided, the process needs to search in its data store to see if somebody else has already chosen this username. And the search result is from this data store to process 1. The validation process has 3 outputs. First, if both username and passwords are valid, a pass information is sent to process 3. Process 3 then adds the new account to user's data store. Also, it sends to the user registration complete information. On the other hand, if either the username or the password is invalid, then this process 1 would send either invalid username or invalid password information to process 2, which then creates an error message and sends the error message to this user. And as you can see here, level 0 diagram provides more detailed information than context diagram. Just now we have decomposed context diagram to level 0 diagram to show more detailed information. If level 0 diagram is still not detailed enough, we can decompose level 0 diagram into level 1 diagrams, and the level 1 diagrams into level 2 diagrams, so on and so forth. In other words, we can decompose a parent diagram or a higher level diagram into child diagrams or lower level diagrams. We could continue to decompose. And finally, we have primitive diagrams, which couldn't be decomposed further. And this figure shows the entire process of creating diagrams. First of all, we have a context diagram, and then we decompose context diagram into level 0 diagram. And this level 0 diagram here is decomposed into 3 level 1 diagrams. Diagram A, diagram B, diagram C. And diagram A is decomposed into level 2 diagram A.1, A.2. And this A.2 is decomposed into 3 level 3 diagrams, A.2.1, A.2.2, and A.2.3. And finally, level 1 diagram C is decomposed into level 2 diagram C.1 and C.2. In this whole process, diagrams A.1, A.2.1, A.2.2, A.2.3, diagram B, and then diagram C.1, C.2 are primitive diagrams because they are not decomposed further. we do not decompose these diagrams because they are detailed enough. In level 0 diagram, we have 3 processes: process 1, process 2, and process 3. We may compose each of them to create a level 1 diagram. So we may have 3 level 1 diagrams. For example, we wanted to create a level 1 diagram to show detailed information regarding process 1. As you can see here, process 1 communicates with user, which is an external entity. It also communicates with process 2 and process 3. Finally, it retrieves information from this data store. As for process 1, all of its communications, that is, all of its data flows, must show up in the level 1 diagram we create for process 1. Here is the level 1 diagram for process 1. So as we can see here, process 1 is decomposed into process 1.1 and process 1.2. Process 1.1 is responsible for checking username. It checks username based on the username provided by the user, and also information from the data store. As I have said, each username must be unique. And then depending on whether the username is valid, it either outputs username pass or invalid username to other processes. Process 1.2 is responsible for checking passwords. It starts work after it receives this username pass from this process 1.1. So which means process 1.1 and process 1.2, they work sequentially. So this process requires an input from user, which is the 2 password data entries from user. Then it outputs either pass or invalid password. So this level 1 diagram doesn't show the external entity, which is user, because we want to simplify the diagram. And the information regarding who provides username and passwords is already shown in its parent diagram, which is level 0 diagram. Right? Because we know that from this level 0 diagram, we know it is this user who provides username and passwords to this process 1. And for the same reason, this diagram doesn't show process 2, nor process 3, nor data store. We need to balance data flow diagrams. Balance here means parent diagram and its child diagrams describe the same process in different levels of detail. They should be based on the same story and shouldn't contradict each other. For example, in context diagram, there are 4 data flows between user and the system. Then in level 0 diagram, or diagram 0, though the system is decomposed into 4 internal components, that is, 3 processes and 1 data store, the system as a whole still has exactly the same 4 data flows with user. So if we cover the 4 internal components, and then we have something like this. So as you can see, the entire system in this diagram 0 still has exactly the same 4 data flows as in the context diagram. We have an example of unbalanced data flow diagrams. We have a context diagram, and then we have the corresponding level 0 diagram. In the context diagram, this system communicates with 2 external entities, entity 1 and entity 2 diagram. In level 0 diagram, the system is decomposed into process 1 and process 2. So if we compare the two diagrams, we could immediately detect the inconsistencies. So for example, we can do this. We can just we can cover the two processes. Right? So this would be this box would be the system. And as you can see here, the first inconsistency is in level 0 diagram, we have 3 entities, and the entity 3 doesn't show up in the context diagram. The second inconsistency is in this level 0 diagram, data flow C, its direction is from entity 2 to this system. But in the context diagram, the direction is the opposite. It is from the system to entity 2. So here we have 2 inconsistencies. And as a result, the 2 diagrams do not tell the same story. Then how to correct the mistakes? Suppose the level 0 diagram is correct. Then we need to modify this context diagram so that it is consistent with this level 0 diagram. And here, this context diagram, the correct context diagram would be just like this. So we need to add entity 3 to context diagram, and also we need to include a data flow, which is just like here, which is from the system to entity 3. And also we need to reverse the direction of this data flow C. And after that, if you cover the 2 processes in the level 0 diagram, as you can see, if you compare these 2 diagrams, they are totally consistent.